science today. We are starting on page 52. We're going to be doing the comprehension check first. Is everybody there? Raise your hand if you're not there yet. 52. You're not there yet? I said raise your hand if you're not there yet. Alright, so looking at the comprehension check, there's matching. You can be looking in the blue box. That's where your answers are going to come from. This able to flow and spread out to fill the shape of a container. Liquids, very good. Liquids. By the way, one of the experiments they wanted us to do was to take different shaped containers and pour liquids into them, but I'm like, you guys know that liquid's gonna take up the shape of the container, right? I just felt like that was unnecessary to just get a bunch of containers and pour water into different containers. You can do that on your own if you want. Number 2, able to keep its shape. Solids. Like this. Able to fill up a space but can easily escape.
Gases.
Alright, now I'm going to give you an item and you need to tell me would it go under solid. We're not going to really write them because we can't write in a book, but you're going to tell me if it's a solid, a liquid, or a gas. Alright, so carbon dioxide. Gas. Very good. Cotton.
Solid.
Glass.
Solid.
Helium.
Gas.
Honey.
Liquid.
Juice.
Liquid.
Oxygen.
Gas.
Oxygen is what you breathe. That's a gas. Plastic.
Solid.
Syrup.
Liquid.
Water.
Liquid.
Wood.
Solid.
Alright, very good. Alright, so let's review. Solids are tightly packed together. Liquids
can
are more
flow.
loose and they can flow. And gases
Can easily
easily escape. Alright? We have a lot of movement. Alright, are you raising your hand? What?
Is gases a plural noun?
Gases would be a plural noun, and we'll learn the rule for that too. That's why a gas, it ends in an S. That's one of the rules that we're going to learn. S, so it's going to add ES instead of just S. So very good. Gases is plural. All right, page 53. Let's start there. You should be on page 53. How does energy change matter? Each molecule contains the information needed to be the matter it is supposed to be. In fact, in everything we find in creation, we find within it the information or plan for it. Where did this information come from? This information could only have come from very wise planning. God has a wise plan for everything He created. His orderly design of matter shows us this. God designed each molecule that makes up each kind of matter. He even planned the way the molecules work and a way matter can change its state. Alright, so I want everybody to look up here. Alright, so these are the states of matter. They are
Solid, liquid, gas.
I need you to pay attention up here. So we're saying that matter can change its state. It can change from a solid to a liquid or to a gas. Does that sound weird? But can matter change its shape? Who can tell me the most common one that we've already been talked about that we know can change its shape? Ice. Ice, when it melts, becomes a
Liquid.
Right, so it started out as water, actually, didn't it? It started out as a liquid, and then you freeze it, and it becomes a
Solid.
right? So ice is a solid. But if you put that same liquid on the stove and start to heat it, what happens to it?
It's a
It
liquid.
evaporates into a gas. Alright, so that water evaporates into a gas. Alright, so liquid changes to a gas. So it's changing its state, right? It is the same thing though, isn't it? It's still water. The water changed from a liquid to a solid or from a liquid to a gas. Alright, so let's talk about freezing. Water is not always a liquid. Can you think of what we call solid water? Ice. Is ice still water? Of course it is. It is now solid or frozen water. How does liquid water change into solid water? When heat energy is taken away, so if you take away the heat energy, it's going to become colder, right? So when heat energy is taken away from liquid water, the temperature drops. The molecules in the water slow down and begin to pack closely together. What state of matter has molecules that are packed closely together? Solids. If the temperature drops to 32 degrees Fahrenheit, water begins to freeze. So those liquid molecules, which are looser and can flow, start packing tightly together to form a solid. Turn the page. Melting. So now let's take the ice and let's turn it back into a liquid again. If ice is heated above 32 degrees Fahrenheit, the ice begins to melt. When heat energy is added to water, molecules start moving quicker. Instead of being packed closely together, the molecules can move enough to be only loosely connected. Do you remember what state of matter is only loosely connected so that it can flow? Liquid. Ice is not the only thing that can melt. Other things can melt too. Candle wax melts after the wick is lit. Crayons are made of wax too. Have you ever left a crayon in a hot place? Anybody? What happened? It melted. Butter can melt too. Melted butter makes popcorn tasty. Alright, so butter is a solid if you have it in the refrigerator. But I keep some butter on my counter so it's soft. So I can actually spread it easier. Because when you get that butter out of the refrigerator, it is hard to spread. It actually tears up the bread when you're trying to spread it on the bread. Alright, but you can even put it in a microwave and melt it down to a liquid, can't you? Instead of it just being soft. Alright, let's go with boiling now. Enough heat energy can make liquid water boil. What do you think is happening to the molecules now? They are moving even faster. The molecules are near each other, but they are not touching. What state of matter does that?
Gas.
That's right, gas. The gas that begins to escape is called
Water vapor.
Alright, so water vapor is water as a gas. Okay, that's what you call water as a gas. Yes, Grant?
When I make toast, I just put the toast on the butter and I just put it in the oven with it. Well, whatever.
Alright, the next thing we wanted to do was have us mark the level on a bowl with masking tape, and we're going to watch as that water level goes down. And we may do this, but there's another time when they ask us to put one in the sun and one in a shady spot and see which one evaporates faster. And I sort of like that one better. So we'll still be doing the same thing that they're wanting us to do here. You could do this at home if you want. You could just put some water and put a piece of tape, masking tape, to mark where the level is and watch the water evaporate. Because it's going to evaporate. Even if you don't boil it, water is going to evaporate. It's going to turn into water vapor just by sitting it out. Okay, but I'm going to wait and we'll do this experiment when they tell us to put one. And it's going to take days. It's not going to happen like that. So I usually put one in the window back there so it's sitting in the sun. And then I hide one over in the corner where the sun's not shining on it. And we just compare them after a week or two so that we can see. And sometimes I'll pull them out just so we can see if anything's happening yet. But which one do you think would evaporate faster?
The one that's sitting in the sun.
Yeah, the one that's sitting in the sun, because that heat is going to make that water turn into water vapor faster, right? Because isn't that what turns water into water vapor? Heat?
Yeah.
All right. And then let's do the true or false down at the comprehension check. Matter can change its state.
True.
True. We just talked about that. Water can become a solid, go from a liquid to a solid, or from a liquid to a gas. All right, adding heat energy to water will make it freeze.
False.
It will make it melt. Adding enough heat energy to water will make it boil.
True.
Water vapor is a kind of liquid.
False.
Water vapor is a
Gas.
All right, give an example of matter that can melt. We talked about several.
Ice.
Ice. Ice can melt. What else can melt?
Butter.
Butter can melt. Dane? Or two other things we mentioned today. Leanna? Allison? Crayons. And one more thing we mentioned.
A candle.
Candle wax. Candle wax. Alright, and what do we call solid water?
Ice.
Very good.